Okay, so today we're going to discuss a very simple yet powerful machine learning tool called FF3. FF stands for Fast and Frugal. So ibig sabihin yan, fast and frugal. Fast, well, yung processing time niya medyo mabilis, no? Kasi dalawa lang yung variables na tinitingnan natin. Frugal kasi it tries to limit. Ninilimit niya yung mga predictors. Kaya frugal, kahit na i-load mo sa kanya mga 15 predictors, it will limit it. May algorithm siya na ginagamit na limited yung ano. The biggest number I've seen is 5. So kahit na 20 ang response predictor variables ang ilagay mo, linilimit niya. I've seen up to 5. I haven't seen a model na more than 5. So I think 5 yung pinaka-limit niya. But that's my I don't know really kung ilan yung maximum niya. Pero so far, okay, 5 pa lang nakita kong pinakamarami. So let's just have a brief review. Yung in decision tree, may nakaano ba? Parang may
background noise.
Oh, may background noise. Kanino yun? Hindi naman sa akin. Yun. Can you hear me?
Yes po.
Okay.
Yes, sir.
Yeah. Okay, so recall lang natin guys yung what we have been discussing so far. Again, guys, let's situate ourselves where we are in now. We are looking at tools in machine learning. No? So and then babalik tayo dun sa trading software where we're going to use again yung quant mode, tidyverse, tidyquant, and TTR for trading. Okay, so if you recall guys, sabi natin yung decision tree, it's a machine learning tool that's used for supervised learning algorithms. No? Supervised kasi alam natin yung output natin, alam natin yung response variable natin, alam natin yung outcome, alam natin we know what we want. For example, we want to determine, given this data set, which we have a variable and we'd like to predict, no? Kung binary siya, kung yes or no, okay, kung magkaka-heart attack o hindi magkaka-heart attack, kung magfa-fail o hindi magfa-fail, etc. So that's the parameter. It can be of course multinomial. No? Pwedeng maraming, parang yung cardio data set data natin, yung suspect, yung NSP. I think we use that here, diba? Normal, suspect, and pathologic. That can also, diba? Yun ang natin, diba? So pwedeng multinomial, tatlo, more than 2. So that's what decision tree does. A decision tree can be handled, can be used for regression. And yung ginawa natin dati yung sa classification. Kaya ang tawag nga dito, CART, yung mga softwares, yung mga packages na ganito, ang tawag sa kanila CART, C-A-R-T, classification and regression trees. Okay? So, as I mentioned here, it can work for both categorical and continuous input and output variables. So, ang kagandahan ng decision tree, very flexible siya. Wala tayong restriction kung siya, nominal or categorical yung variable or quantitative. No such restriction. And madali siyang i-interpret, madaling i-implement, madaling i-interpret. And as I say here, they closely mirror yung psyche natin, yung mind natin, kung paano tayo mag-decision making. Okay, so ganun parang compartmentalize mag-isip yung human brain. So the decision tree is quite similar to how we think. Yun ang approach na ginagawa niya. Okay, so also decision trees can be displayed graphically and pwedeng, unlike pag-regression lang, na kailangan kapag categorical, kailangan mag-create tayo ng dummy variables. Ang decision tree, hindi. Whatever kind of variable you have. Okay? Now, a tool for decision tree is the FF3s. Si FF3s, package siya, developed by Nathaniel's I think the name is Nathaniel's. Tapos, but siya din-develop. Let me quote yung sabi ni Malcolm Gladwell. I don't know if you have read his book on Blink. Sabi niya, as human beings, we are suspicious of rapid cognition. We live in a world that assumes that the quality of a decision is directly related to the time and effort that went into making it. So in other words, pag masyado mabilis yung yung decision-making process, parang question natin, ano ba yan? Ang bilis naman na nag-decide na kaagad ng ganyan? Bakit, for us, it took us several weeks to come up with a decision kasi talagang we were really very, very thorough in analyzing and coming up with a decision. But we tend to question, guys, kung mabilis yung decision making. But there are researchers that say that the longer does not necessarily mean the better. Kasi sabi ko nga, sa folk wisdom, more time, more information used, and more effort will make our decision better. Okay? But yeah, I mentioned a while ago, more is better. For example, yung mga doktor na magagawa ng decision, the more tests, the better, para sure lang. Yun ang sinasabi nila. Pag nag-i-invest sa stock market, di ba, ang common connotation, get as much data as you can and even build a statistical model that's so complex that it describes the past perfectly. However, may mga researchers kasi, may mga researchers sa psychology, sa behavioral sciences, sa cognitive science, and machine learning also have shown that the more is better theory is, in many instances, it's flatly wrong. It's like saying that the earth is flat. In many real-world decisions, hindi naman necessarily the more is better. There were many cases, ito I'm quoting from this person who did the research, sabi niya, less is more. For two reasons. Number one, yung statistical reason. What about statistical reason? Kasi kapag masyadong complex yung parameters natin, okay, we're trying to have a model where you're trying to predict a certain variable, and then you're using 1,000 predictors. Naku. Sa regression, ang tawag dyan sa problemang yan, overfitting. Kaya nga di ba, so far what we have done is to split our data into a training data and to a testing data. Di ba? So that we avoid overfitting. Overfitting occurs when the model is very good at describing a specific past data sense. Pero pag in-expose mo na sa bagong unseen data, wala na. Kunyari, nag-confusion matrix ka. Tinignan mo yung capability niyo to predict correctly, ang layo na dun sa nung ginamit natin sa training data. Okay? Example, you might be able to come up with a very complex economic model using past stock prices very well. So siguro intraday pa yung ginagamit mo every minute, Every minute yung ginagamit mong data, and you're able to predict yung past data to the nearest minute. Pero nung in-expose mo na sa bagong data, wala na. It failed miserably. Kasi nga, because of overfitting. Okay. And sabi nga ni Burton, sabi niya, it's so hard for complex trading algorithms to outperform simple index funds in the stock market. So there's a study conducted about that. Aside from statistical reason, meron din tayong tinatawag na psychological reason. Sabi, if a complex, sorry guys, just to have an economy of words, if a complex decision model is good at predicting new data, if a person can't understand it or easily implement it in the real world situation, okay, then sayang lang yung model na yun. Hindi gagamitin yun. Okay? Then enter FFT. In many cases, guys, importante yung makaderive tayo ng decision and then with the economy of data. Kasi pag masyadong maraming gagamitan ng data, tatagal. So itong FF3s developed by Nathaniels, no? Apat silang na-develop nito. And usually 1 to 5, no? 1 to 5 pieces of information and ignore all other information. So they will take a look at the information. Lahat titingnan naman. And they will take a look at what pieces of information will generate the lowest sum of the squares of the residuals or error. In other words, guys, past FFT are non-compensatory. Ano ibig sabihin ng non-compensatory? Pag may ginawa ng decision based on these few pieces of information, kahit na magdagdag ka ng additional information, hindi na magbabago yung decision. Okay? Besides the ease of use, very simple to use, okay, ginagamit siya, they have been used in real world decision tasks. So this is not just a very theoretical or parang nice to know, but no practical use. Okay? Ginamit na siya sa maraming practical usage, like to predict kung may coronary heart disease, no? Or in fact sa psychology ginagamit din to to predict depression. Okay, so may gamit talaga yung tool na to. Okay? All right, so I mentioned here, okay. However, lest you think that FFT are only useful when time is limited, research has shown that FFTs can outpredict. So may mga ganong studies na tinatalo pa nila yung more complex models and decidedly non-human simulations. So may mga ganong cases na kinumpare nila yung performance ng FFT compared to yung mga more complex models, in-outperform ni FFT yung mga models na yun. Siyempre, may mga limitation to. Wala naman talagang mga sophisticated na softwares na talagang nagde-develop ng mga programming tools na ganito for FFT. Pero it's good that in R right now, meron na tayong package na FFT. So this was written before, no? So ang common complaint dati, walang medyo sophisticated na package or software that can produce this FFT. However, now guys, with the advent of R Studio, so meron ng package na ganito, FFT. So ang gagawin natin, mag-create tayo ng FFT object ngayon. So we will derive a model and try to see how good the model is in predicting, no? In predicting. So let me see. So ang FFT guys hanggang siya, binary lang siya. So parang logistic regression. All right. So install muna natin guys. I'm sure you haven't installed FFT, so kindly install that now. If you notice guys, may mga blanks dito kasi I want you to be writing them on your most of the from now on guys, more on na tayo. Kayo na magsusulat, no? FFT, take note guys, ano siya yung capital. Okay, I won't run this anymore kasi naano ko na siya. And then, once you have done that guys, i-library na natin. When you're done, guys, kindly chat.
Sir?
Yes?
Nung ginenter ko yung code, tas na-run ko, sabi niya, FF trees is not available for this version of R.
Sandali Ayaw? Okay, if it does not... okay. Hindi siya nagra-run sa version ng R. Tingnan nga natin, guys. Hanapin nga natin sa ano.
May link siya na binigay, sir.
May link na binigay sa GitHub.
Version of this package
Development tools. Kung ayaw, FF3s does not install.
Tignan ko lang yung link.
Oo. Baka sa GitHub yan. Baka sa development, ano?
Cran daw.
Ha?
Cran.r.project.
Kung ayaw niya sa ano, tingnan natin ha. Okay, baka magbigay dito ng ano, ng sa GitHub, alam ko pwedeng i-download sa GitHub to. Okay. FF3 is not available for R version. Ano yung version ng R mo? William.
How do I...
Tingnan natin R.version. Yan. Type mo nga siya.
Oh, okay. Hold. In the group. Internal. Oh, do I have to get the code? May code na lumabas.
Saan?
Or is this wrong? Mali ata yung in-enter. Ayun. Okay. I think. Platform. Which one am I looking for, sir?
Yung version ng R. Yung version ng R.
Version string?
R.version.
R. Oh. Ay, di, sir, yun yung in-enter ko. Pero yung sa lumabas, medyo marami.
Makikita mo dyan yung version niya.
Yung sa pinakababa pa, sir.
Yeah, 4.0.
Yung version string?
4.0.
4.1.3.
4.1. Oh, mas advanced pa nga yung ano mo, no? So, dapat... okay. Tignan mo nga kung ma-install mo dito sa ano. If you can install it here sa packages. Go to packages and then FF3s.
Wala din po, sir.
Wala din yung FF3s dito. Okay, sandali ha. How do we resolve this? Tingnan natin sa ano, sa either sa Stack Overflow. Okay, I know meron siyang development hub eh. Yung development hub, kung hindi ma-install from Quran, then we can access it from FF3's natin development hub.
Up.
Tingnan natin to. Yan si Philips pala, no? Subukan nyo nga to. Ito. I'll send it in the chat box. Gamitin natin si DevTools. Okay.
And then we just, sir, just enter it like a code.
Sorry.
We enter it as if it was a code.
Yeah, oo.
Or
yeah. So install that packages, DevTools, and then install run this DevTools, yung function na install GitHub, and then andito yung ndphillips/ff3s.
may nag-pop up, sir.
Ha?
May pop-up na lumabas.
Anong pop-up na lumabas?
One or more of the packages to be updated are currently loaded. Restarting R prior to install is highly recommended.
Yeah, yes. Okay lang yun. Okay lang. Oo. Sa'yo, Cells, mo okay?
Hindi rin po, same nung kay William.
Same din. Okay.
Pero nung pinipaste ko na po yung yung link, unexpected symbol.
Saan? Dito? Ito? Yung
Wait.
sinend ko?
Opo.
Check mo, baka yung quotes, minsan yung quotes, ano eh, pag kinopy mo siya, and then pinaste mo sa RStudio, hindi siya yung hindi siya yung quotations na stop share ako and any one of you can share your screen if you want.
Yes, sir. Naka-disable po yung...
Sorry.
There's no package.
Okay, ano pala, no? I-ano ko kayo, gawin ko kayong co-host, no?
No packages. Yes. Error in install. Whoa, what happened? Oh, okay.
Ito po.
Saan
Kita nyo
yung
na po.
tingnan mo? Install that packages, dev tools.
Nag-install ata sa akin, sir.
Nag-install sa'yo. Yung
Yeah, pero weird lang is I hit no and then it installed. Like when I hit yes, it didn't work. And try mo
Yan.
no.
No ba dapat? Sorry. Yes ko.
Try mo. Yung no ko gumana.
Ganun.
Parang-
Dapat mag-yes yan. Sige. Subukan mong May FF3s na ba?
Wala pa po.
Wala pa. Capital kasi wala pa rin.
I mean, yung development tools yung gumana.
Sige, ulitin mo yung development tools. Yung na lang, yung second na lang kasi na-install mo
Ito
na
po?
yata. I-library mo nga siya. Library DevTools. Small lang.
Dito na lang.
Oo.
Dev.
Small
Wala
D.
po.
Small D.
Small D.
Wait, what? These packages are more.
Wala po.
Pero na-install mo na, di ba? I-run mo nga ulit. Celso yung install. Oo. Kahit yung install muna, install that packages muna.
Yung itong dev tools.
Let's do it one at a time. Sige, yan. Escape mo na yan. Ayan. Escape nga.
Ayan.
Ayan, sige.
Tapos,
Control Enter mo. Yan, hintayin natin mag-install siya.
No, try mo no.
Sabi ni no daw. Subukan mo no.
Huh?
Pero nag-run na kanina.
Ay.
ayan.
Yeah,
Install na siya. Oo. And then i-run mo yung second line, yung sige, wait for that.
Oh, there. Installing source packages FF3s.
Yan, good. Hintayin natin si Celso.
Pero medyo matagal siya, sir.
Matagal?
Kanino ko pa siya ginawa, sir. Kasi ngayon lang na siya gumagana.
Sige, okay lang yun. Okay lang. Kasi wala tayong magagawa kung hindi natin ma-install. Yan ang natin, yan ang gagamitin natin ngayon. So we need to install that. By hook or by crook. And
That's the
DevTools.
library.
Ayan. Downloaded na.
So yan na yung DevTools natin. Oo. Tapos, i-library mo nga.
Ayan.
Yan.
Dito na po.
Sige. I-ano mo na yan. Click mo na yan. Okay.
And then yung second one.
Alright. Yung second one,
Second
yung
one.
DevTools, yung GitHub.
Chat. So,
Mag-arrow up ka.
ito po. Dev tools. Ayan. Dev tools install.
Yan. Oo. Yan.
you have to enable the DevTools.
Ayan.
Yan mo kung okay.
You run the second line, sir, after library using the library of
yeah.
DevTools.
Oo, i-run mo na.
Okay.
Oo, kasi
Oops.
kahit na, di
Kaya
ba,
pala.
kahit na na-install mo na siya, it doesn't necessarily mean na automatically magagamit mo siya, di ba?
Skipping install.
Installing the package.
Was
Yan na,
meron na.
nag-install na yung kay Celso. Yan, nag-create na siya ng vignettes.
Sir, question. So yung sa packages tab doon, it's the same as using the library code?
Sorry?
Pag na-click mo yung sa tick boxes ba dun sa packages, is it the same as using library?
Yes, oo. Oo, pareho lang yun. Kasi nakalagay din sa taas, di ba, user library. No?
Yeah.
So nagkikreate pa siya ng vignettes. Hintayin natin kay Celso mag-run. Mag-okay. Malakas ang ulan dyan, Cel, sa inyo?
Ano po?
Malakas ang ulan?
Tumigil na.
Tumigil lang po ba yung ulan dyan?
Tumigil na.
Yun. Okay, yan na. Lapit na. Installing ano na. Okay, sometimes guys that happens, no? Minsan wala pa kasi sa sa CRAN, pero yung developer ng package, inaalaw na niya, yung sinishare na niya, yung package kahit na hindi pa naka sa CRAN, kahit hindi pa naka-deposit doon.
FF3. So,
yan na. Yan, okay na yata. Sige. Pakihanap nga sa packages. Done na. FF. Kung wala, sige, i-ano mo na lang. I-type mo na lang library.
library.
Wrong spelling pa yata.
Oh.
Sa library kahit walang quotes, pero okay lang din naman. Pwede rin yan. Ayan, very good, very good, very good. Okay, so that's sign na andyan na yung FF3s. So we can now use the functionalities of the FF3s. Okay, sige, share ulit ako ng screen ha. Thank you. Okay, so let's go back to our file. Okay, now yung sa FF3s guys, may mga data sets diyan na available which we're going to use in this case. So alamin nga muna natin kung ano yung mga data sets. Kindly check kung naka-load sa inyo si VCD Extra. Tingnan niyo to guys, VCD Extra. Kung wala, paki-install na rin to, no? Para magamit natin yung. There are different ways of loading the package or the data sets in a package. So this is one of them. Do you have VCD Extra installed in your machines? Kung wala, guys, paki-install ulit, no? Install that packages. And if you're done,
both
yes.
VCD and VCD Extra?
Yung extra na lang. VCD Extra. Kasi yun lang gagamitin natin na we'll just use it. We will just use this to access kung ano yung mga data dun sa data data sets available in FF3s.
It
Okay na po
downloaded
ako.
both pala.
Ha?
It downloaded both.
Okay, good. So once you have downloaded both, ano natin, no? Let's use that BCD extra. Lagyan lang natin namespace para alam niyo kung saan nanggaling. And then P.
Sir,
Yan. Ha?
Sir, yung library ba namin?
Yeah, oo.
Oo.
Dapat i-library nyo, no?
Kasi di mo rin
I-library nyo.
magagamit.
Oo, correct. I-click nyo na lang to dito sa packages. And then P. Bakit wala siya? Ay, hindi, sorry. Not P. Mali. D. Ayan, data sets, no? So BCD extra and then data sets. Okay. Data sets and then ang package natin, package is equal to FF3s. So this will collect, no? Ano yung mga data sets that come with this package FF3s. And if you run this, nag-run na siya dito. No?
Blood,
Hindi pa.
breast cancer, credit
Yan.
approval.
Yan. Nag-run na sa inyo?
Yes po. 1 out of 17.
Okay.
Ano?
Hindi pa nag-run sa akin. Ayan. Okay, medyo mabagal lang. Okay. So here, okay, hindi lang, expand lang natin para para makita natin ang buo yung Let me run this again. Okay, so you have here the data set, and then the class, and then the dimension. Okay, so you have the blood, breast cancer, car, contraceptive, etc. Okay, mukhang ang nag-create itong Fast and Frugal trees, mukhang nasa medical field sila, no? Kasi lalo sa medical field, guys, kailangan nila yung mga ganyang quick decision eh. So, kunyari, whether a person has heart disease or not, no? Whether a person needs to show symptoms of a particular disease or not. So, maraming gamit. And that's why sa medicine, sa medical sciences, ginagamit talaga itong FFT. Alright, we're going to use this. Okay, may data na siya dito na heart, na in-split na niya, no? Sa test data at saka sa train data. So in this case, hindi na tayo mag-split, we're not going to split it. Binigyan na tayo ng example ng data set. 153, yung response, yung observations ng testing data, and 150 yung training data. Mas marami pa yung yung training data, yung testing data kaysa training data.
Sir, yung heart cost.
Sorry?
Yung heart cost.
Heart cost, sandali.
Opo, isa po yung data yung sa above ng heart test.
Heart test. Ibang data naman to, no?
Iba. Tama. List naman.
Ang gagamitin lang natin iba. At saka list siya, no? Hindi siya data frame. So ang gagamitin lang natin tong heart.test at saka heart.train. Okay, so just remember that, no? Heart.test and heart.train. Okay, so sige, i-ano na natin, no? Before we do, yes?
Sorry. Question lang.
Yes.
Is it supposed to populate the data individually in the data window?
Sorry?
Yung sa'yo, sir, kasi diba may the window at the bottom, there's data.
Yes.
It's supposed to show up there, diba?
Yes, oo. Ba't sa'yo hindi?
Mine, no, sir.
Ayaw? Sige, i-show mo nga yung screen mo.
Ito lang, nag-run naman siya, sir. Tapos nakikita ko dito sa...
Yan siya, di ba?
Wala siya dito, sir, sa ilalim.
Dito sa environment.
Gumawa siya. CC torture.
Which one? Yung values sa environment.
Sure. Tapos check naman yung iba. Wala.
Okay, sandali ah.
Run ko kaya ulit, sir?
Actually, wala pa tayong linoload na data. Ito, kanina ko pa linode to eh.
Okay,
Oo.
sorry. Kala ko,
Wala
I thought it was supposed to...
wala pa.
Okay.
Ito
Sorry.
it's okay, William, it's okay, no? I should have erased this. Erase ko na lang para ayan. Okay, i-broom ko na lang siya. Okay, so just like you guys, wala, empty pa yung environment, no? Celso sa'yo din, di ba?
Yes po.
Empty pa kasi wala pa tayong linoload na data. Okay.
Sorry.
Advance si William.
It's okay, William. Oo, advanced talaga si William eh. Yan talaga kapag may bagong trabaho na eh.
Hindi kasi diba, nakita ko yung akin, tapos nakita ko yung sa'yo, sir. Ba't nandiyan na? So, isip ko, alam ko na pinag-copy sa akin.
Wala pa tayong re-release na data.
Ganyan din ako nung bago ako eh. Lahat nagawa ko na kahit di mo sinasabi eh.
Sige. Okay, William, share ulit ako ah. Stop share ka na muna. Okay. Alright, let me share once again my screen. Okay. Now, always guys, it's a very good practice to try to learn first kung ano yung package na yan. Ang pinakabida na package natin dito is si FF3s. No? So, ako lagi kong ginagawang practice, hinahanap ko yung documentation sa CRAN. So I already got the URL. Kunin nyo nga guys, so then i-open natin. Okay, andito na ba yun? Para hindi ko nabuksan. Okay, Control V. So of course we can generate this dun sa help function in R, but you can download this PDF, 36 pages of documentation. So ang nag-develop nito si Nathaniel Phillips. Okay, so ang description niya to create, visualize, and test FFTs. So this is specifically created for FFTs, which he describes as a very simple decision tree for binary classification problems. Okay, take note yung limitation ito ginagamit lang to for binary classification problem. So you cannot use that for you cannot use it for multinomial more than 2. FFTs can be preferable to more complex algorithms because they're easy to communicate, require very little information, and are robust against overfitting. Okay?
Sir, question
Yes.
po.
Sabay pa tayo.
Yung variable, sir, talaga po bang strict siya na dalawa o mamimili lang siya ng dalawa dun sa multiple variables na meron ka?
When I say variable, wait, baka na-misinterpret nyo. When I say variable, yung variable of interest natin,
Yung predictor, sir.
yung dependent variable, yung outcome variable, yung response variable. Okay, ipapakita ko in a while, no? Tapos
Okay.
yung mga predictors, pwede marami. Okay, not necessarily dalawa lang. Pero yung yung response variable natin, it should be a categorical variable, tapos binary lang siya. Parang true or false, yes or no, 0 or 1.
Okay.
Okay, yung response variable natin. So, this is akin to a logistic regression model. Di ba, nag-logistic regression tayo? Kunyari, may heart failure ba o wala? So, pag ganon, guys, pwede itong FFTs. But that's the main limitation of this model kasi hanggang logistic lang siya. Parang yung ginawa natin dati, di ba, nag-GLM ba tayo, guys?
Opo, nag-GLM tayo.
Yeah, tas family is equal to binomial, di ba?
Yes po.
So, ginamit natin yun. So, ganun din. So, in that instance, pwede natin to magamit yung FFT natin. So, sabi nga dito, and are robust against overfitting. Okay. Kasi, ano ibig sabihin ng overfitting, guys? Marami kang variables, pwede 100. Pero pipiliin lang niya. Siya na mismo siya na mismo magpipili ng the best na mga predictors to explain your dependent variable, which is a binary variable. So here you have may mga ito yung mga functions, no? Naalala nito yung rocks natin, yung AUC, yung area under the curve, nung binomial logistic regression. Okay, so ito yung importante sa atin, yung FF3s, no? Tapos let's try to see, no? Ano ba yung mga laman nito, yung mga functions siya. Apply that tree, applies an FFT to a data set and generates several accuracy statistics. Okay, so ito yung syntax niya, no? Apply the tree, yung data, yung formula, tree dot definitions, may sensitivity, may cost outcomes, etc. Okay, so there are quite a number of functionalities here. Blood is a data set, no, dito. So may mga data set din siya. Breast cancer also a data set. Yung tingnan natin yung heart.test at saka heart.test at saka heart.train. So letter H, sana siya? F. Tingnan mo natin itong FF forest. Okay? Ito guys, yung pinaka hindi FF forest, FF3s. Yung FF forest daw, it's in development pa, no? If you take a look at FF forest, yan. Creates a forest of fast and frugal decision trees. So pag nagawa to, no? Currently in development. Ito guys, mas powerful to kaysa sa FF3s. Kasi ang mangyayari nito, several FF3s, no? Yung FF3 kasi
forest.
Yeah, forest siya. Oh, kaya nga isang lesson natin yung random forest, no? One of the most powerful machine learning kasi pag random forest, you can now create several decision trees. So far kasi ginagawa pa lang natin isang decision tree lang, di ba? Yung party package, yung R-part package, isang decision tree lang 'yon. Imagine creating 500 decision trees like that. Oh, saan ka pa
lang yung name niya, sir.
Ha?
Nakakatuwa lang yung name niya.
Oo nga.
Nakakatuwa yung name. Kasi yes. Trees, tas mas malaki sa forest.
Correct. Forest siya ng frugal trees, no? Oo. So, pinapatan siya after yung RF, no, random forest. Kasi yung isa sa pinaka-powerful machine learning tool, yung random forest, it's a lot more powerful than decision trees. Kasi yung decision trees, isang decision tree lang yon. Okay, kung gusto mong iba, mag-create ka na naman ng panibagong model. Yung random forest, you can create in one code 500 decision trees. Tapos i-average yun. Yes.
Are those trees like related in that case? Or they're from the same variables?
Oh, same data set, no? Same data set.
Okay.
Tapos nagko-cross validation siya niyan. Ibig sabihin, binabago-bago niya yung training and testing. So different combinations.
So it's for like a consistency thing.
In a sense, yeah. Oo. Okay, so we're not going to use the FFF, no? Ang gagamitin natin yung FF3s. Ito. Here. Creates a fast and frugal trees object. So isang isang tree lang to. As it is described here, this is the workhorse function. Ito yung talaga, workhorse ng FF3s package. It creates one or more fast and frugal decision trees trained on a training data set and tested on an optional data set. So dito kailangan i-define natin kung ano yung, if you take a look at this, andyan yung data.test. Okay, andito yung data, yung training data, dapat i-define natin, at saka yung testing data natin. Okay? So we'll do, tapos meron pa siyang support vector machines dito, no? May cart siya, but we're not going to go there. Yung simple lang na FF3s ang gagamitin natin. Alright. So sige, let's continue. It's always a good idea. Ito yung heart.cost, no? Ito yung sinasabi ni Celso kanina. It's also a data. Data din siya. Alright, so going back. So, sabi natin, di ba, maraming data set, 17. But we're just going to use two, yung heart.train at saka yung heart.test. Okay? Pag nag-FFT tayo, pag nag-frugal and fast twist, dapat naka-define na yung training data natin at saka yung testing data. Okay? So, since nagbigay naman siya ng sample dito, gagamitin na lang natin yun. Alright? So, let's load that, guys. Load that. So, siyempre, data. We can already access that heart.test. Train muna. Okay. Alright. Data. Okay. Tingnan natin. View. Hindi na-load ko na ba si Okay, let me load first. Baka hindi ko pa na-load si FF please. Hindi ko pa yata na library. Error. Oh, bakit wala? FF. Ay, mali. Mali yung spelling ko. FF3s. Okay. Alright, na-load ko lang si FF3s. Then we can now... yung help dito guys, yung lang di ba? Yung question mark, FF. Oh, yun lang yun. Okay, so let's load this heart.train. Heart.train. Okay, medyo matagal. Nag-error ba? Bakit?
Yes, sir.
Heart.train.
Error in view.
Heart.train. Ulit.
Added first argument. Ay,
Not found.
train not found.
Bakit? Yeah, natin FF. Not found. Okay, let's see. Heart. Dot. Ayun Ayun naman siya. Ayun. Ulit. Heart. Dot. Natin ang This is weird. Okay. Kung diretso natin, view. Pag view nakikita, ano ba yan? Pag data, ayaw. View nyo guys, lalabas yung heart.test.
Yes po, malabas.
Diba? But pag data, ayaw. Pag data sets, tingnan natin. Data sets. Hindi, data sets kasi ito ang package. So, wala, no? So maybe it's, siguro sa syntax ng FF3s mismo, siguro hindi sinama yung data mismo. So anyway, access na lang natin heart.training set. Okay? And then maglagay na rin tayo ng head. Hindi na, doon siya. Sige. Heart.train. Kahit yung first 6 lang. Okay. So let's run this.
Di po ba automatic yun na first 6 lang kapag head yung ginamit?
Tama. Pag
pag head po, automatic na first.
Automatic. Ano ba ginawa ko? 6. So redundant na to, no? I could have used another number if I want, 10. Yan. But I'll just look at this one. Okay. So ito guys, yung natin, mga variables natin. This is all about, tingnan natin yung tingnan natin yung Ano laman itong dataset na to? Yan. Heart.train from the package FF3s. No? Training data for a heart disease dataset used to train a model. Okay, so ano yung mga variables? Age, sex, gender, 1 is equal to male. CP is chest pain. Okay, chest pain, typical angina, atypical, and mga medical terminologies on. Resting blood pressure, serum alcohol, etc. Ano nga ba itong thal? May thal, may CA diagnosis. 1 is equal to my heart disease. 0 is equal to no heart disease. So we're given this respondents. So in-interview nila, tinanong nila yung gender, yung age, yung blood, ano ba to? BPS, resting blood pressure, etc. No? And then nalaman nila kung may heart disease o wala, no? Okay, so these are actual. Okay, so nalaman nila kung yung tao may heart disease o wala. All right. So okay, di ba naalala nyo kung tayo gagawa nito, isa-sample natin siya para maano yung ordering. Ito binigay na naman sa atin, no, na yung heart.train dataset. Hindi natin alam how it was done, no? But let's just trust that random yung pag-generate nila ng heart.trust at saka heart.train. Okay, so let's go. This data frame contains, ilagay na rin natin yung yung isa. Kaya access na rin natin view heart.test. Check natin head heart.test. Okay. Run natin pareho. Okay. So pareho lang guys, 14 yung 14 yung
by 14.
Yung variables natin, no? Both for test at saka sa train. Okay, let me close that. Okay. So let's go. So dito may description lang ng konti which we already read. Now the goal of the FF3 will be to find a few key variables in the data that can quickly and accurately predict diagnosis. So ang pinipredict natin dito guys yung diagnosis, yung false or true. Okay? Yung false guys, sabi, may heart disease. Okay? Yung true to, no? Yung true may heart disease. Yung 0, no heart disease. Yung 0 guys, false yun. Okay? Yung true is 1. Okay, so let's continue. All right. Now we're going to make use of the FF3s. Okay, kanina tinignan natin, 'di ba, yung FF3s na data na na ulitin natin, no? Question mark FF3s. Okay. So the syntax is this one. Medyo mahaba-haba siya, no? Kung if you're going really to be very let's say very specific, no? Ito yung function ng FF3s. So we're not going to use everything there. Pipili lang tayo ng yung mga relevant sa atin, no? So let's create this. Okay, let's call it, sabi, heart, and then FFT. Okay, so we're creating this object, heart FFT, alt minus for the assignment operator. So ang gagamitin natin si FF3s na function. Okay, so first, sabi formula daw. So ang formula natin, what will be our formula? Is equal to, di ba rene-regress natin si diagnosis, right? Diagnosis is our dependent variable. Okay, and then we are regressing it, control tilde, shift, sorry, mali. Yan, shift, tilde, yan. Okay, we're going to regress it on all the variables, okay? So, paano natin gagawin all the variables yan, guys? Naalala nyo?
Tuldok.
That, oh. Tagalog na Tagalog yung Celso.
Bulakenyo.
Bulakin. Hindi ba tutuldok yan? Okay, kama, no? So that's the variable that we are predicting, di ba? Lagyan natin ng ano, lagyan natin ng, let's put a, para alam nyo, no? Variable predicted, no? Ito yung pinipredict natin. Of course, hindi babasahin yan. Okay? And then, i-enter nga natin to. And then, ang susunod, ang gawin natin yung data. Ano yung data natin? Data. Sabi, data daw is equal to, ano yung data natin, guys? Si heart.train. Diba? Tama? So, ito yung training data natin. Ayan o, data is equal to, ito yung train data natin. And then may susunod pa ito, data.test. Ayaw makopya. Yan. Control C. Control V. Data.test is equal to heart.test, di ba? Kailangan meron na tayong training at saka testing data. So let's define this. This is our hashtag. This is our testing data. Okay, ano pa? Algorithm. Ano pa pwede natin gamitin dito? Mamaya yung stopping rule. Okay, lagyan natin decision labels natin. Decision.labels, Control C, Control V. So, anong pwede natin gawing decision labels natin? Is equal to C. So, C1, pag 0, kasi 0, 1 yan, di ba? Kapag 0, guys, let's call it stable. Ibig sabihin, walang heart attack, no? And then kapag 1, tawagin natin na H attack. Yan. Okay, diba? Comma, this is our, tawagin natin decision labels. Okay, ano pa? Decision labels, tapos okay. Wala, yung main, no? Lagyan natin ng ng main equals Control C. Label lang to, no? Let's call it, anong gusto nyo? ER, this is ER yata to, no? Decisions, no? Kung ano ba, kung may heart attack na ba o stable lang yung yung tao. Meron pa ba tayong pwedeng isali? Okay. My 3, hindi na. Okay, I think that's okay na muna, no? Alright? So, natin open. Tama ba na? Tama na ang natin. Close. Main is equal to. Tama na yung natin. Tama na, no? Opening, closing. Alright. So, ito na, guys. Gagamitin natin yung function ng FF3s. So, we're creating an object called yung heart, cache, and frugal tree. And then we're going to make use of the workhorse function of FF3s. Gagawa siya ng object na FF3s. I-run natin to. So it's now running. Okay? So we can see here, guys, na si heart FFT, it's an FFT. So medyo hindi natin alam kung anong object to, no? But it's an FF3. Tapos may goal siya na sinabi dito. Okay? May goal siya na sinasabi dito which we don't know yet, no? Okay, so far?
Nag-error sa akin, sir.
Nag-error siya. Check niyo ano, baka may ano kayo, baka may mali dun sa ano Sensitive pa naman si R, konting
Oo nga po.
konting displacement lang ng tuldok, no? Maiiba na yung ano natin, maiiba na yung, mamamali na yung model natin. Gusto mo i-show? Salso?
Ano po?
Gusto mo i-show?
Sige po.
Sige, stop share ako Show niyo po muna, sir. Tingnan natin.
Wala.
Ang liit naman ng ano mo, ng...
Ito.
Yan.
Heart, FFT,
Medyo ano mo nga, i-tools mo, medyo palakihan mo ng konti. Tools, go to tools siguro. Tools, sa taas. Tools, yan. Tapos global options. Yan, appearance. Yan, yung gawin mong palakihan mo ng konti para mas kita naman natin. Yan. Okay. Ayan. Okay. This mas kita. Okay mo na. Ayan.
Heart.
FF3s. Formula. Is equal to ba yan yung formula na yan?
Opo, is
Equal to.
equal to
Tapos diagnosis is tilde. Dot.
Dot.
Okay.
Comma.
Data is equal to
Heart train.
heart dot train. Comma. Data dot test is equal to heart dot test. Tama? Tama. Comma. Decision labels is equal to C. Stable, comma, heart attack, and then close. Comma. Wala kang close parenthesis sa dulo. Dapat meron. Yan.
Oo.
Okay?
Okay po.
Yan.
Thank you po.
Okay. Thank you po. Share screen po ulit ako. Okay, so nakapag-generate na tayo, no? Ng heart FFT na to. Tingnan nga natin kung i-click natin dito sa object. Ano ba tong heart FFT na to? Ayan, no? So parang list siya, pero FFT ang classification niya. So it's a list, no? List of lists siya. It's also a list, no? May list dito, may formula. Ibaba natin to, no? Formula, no? Ito yun, no? Yung parts diagnosis. Tapos may trees, may list ng 7. Okay, may iba-ibang ano, no? May iba-ibang laman to, no?
Okay. Sir?
Yes.
Question: should we have set seed before we did this or no?
No, kasi hindi na tayo nag-set kasi hindi naman tayo hindi tayo nag-create ng training and testing data natin, no? Hindi tayo nag-randomize.
Okay.
Oh,
So, may
Because
binigay,
it came with it already.
yeah, it's okay.
Okay.
Good observation. There was no need to do that kasi given na sa atin yung heart tsaka
You test
yung
and train.
training and testing data. So no need for us to to generate a training and testing data set.
So,
Alright.
may same na tayo na, sir.
Yeah, same tayo dun. Okay, so let me go here. Alright, so pwede natin siguro i-print nga natin, print the object heart underscore FFT. No? So print natin siya. Okay. Alright, so may result ng binigay, ano? Kita nyo guys? Do you have this?
Yes.
Okay, so yung title natin yung main ER decisions, di ba? FF3s, there are 7 FF3s predicting diagnosis. Outcome, so may outcome tayo dito, no? So we'll see anong ibig sabihin itong high, ano yung MI, ano yung FA, at saka ano yung CR. Then ito na yung guys, yung ano natin. Ito na yung decision nodes niya. Ito. If thal is equal to RD or FD, then heart attack na yun. So ito pa lang, isa pa lang, may decision na kagad na heart attack. If CP is not equal to A, then stable siya. If CA is less than 0, stable siya. Otherwise, heart attack. Let's take a look first at our data. Ito, heart.test. So let's see. Ano ba yung laman ng okay. I-check lang natin, no? I-check ko lang dito, table ng ano ba to, heart. Okay, sandali lang let me just may i-off ko lang tong dali. Okay guys, sorry about that. May biglang may tumawag lang na. Okay, so where are we now? So if you recall guys, yung sa tree na ginagawa natin, ito tatlo lang Diba? How many variables did we use? We used all in all 13 predictors. Kasi 14 yung variables natin, yung isa doon si diagnosis, siya yung dependent variable. The other 13 are regressors, no? Pero tingnan nyo, tatlong variables na ginamit nyo, yung thal, yung CP, at yung CA. Tingnan nga natin guys yung wait ito na pala. So dito, heart underscore train. Okay. And then, tingnan natin si thal. Ito, CTAL guys, FD normal at saka RD, no? So tatlong klase. 87 dun, normal, 6 FD, 57 RD. I don't know what this means, no? So if we want to know further, aralin pa natin data set, no? Pero ito yung distribution ng ano niya, ng data niya. Tingnan din natin sumama si CP, di ba? Si CP naman. Ano si CP? Ayan si CP, apat. A, NP, at saka TA. Kasi sa model natin, ang lumalabas, so if TAL is equal to RD or FD, then heart attack na kagad yun, no? If CP daw is not
sir?
equal, yes?
CP is chest pain daw.
So chest pain, okay, thank you. Okay, if chest pain is not equal to A, so ibig sabihin AA, NP, and TA, no? Hindi natin alam kung anong, maybe you can just look no, kung ano yung mga ibig sabihin nito.
Yeah, nasa health naman siya, sir.
Sige, good. Pag hindi siya asymptomatic,
non-anginal pain yung NP, AA is atypical angina, and TA is typical angina.
Okay, good. All right. Pag hindi daw A, guys, not A, then stable. Whether it's AA, NP, or TA, stable siya. And then lastly, tingnan natin yung CA naman. Ano ba yung laman ng CA? Ano to, no? Hindi pa pwede kasi numeric, no? Hindi pala numeric. 0, 1, 2, 3 din, no? So if it's less than 0, less than or equal to 0, then pag 0 siya, stable. Otherwise, pag 1, 2, 3, heart attack yun. Okay? So may summary na tayo guys dito, no? Okay, ito yung HI. Ibig sabihin na based on the model, ano ba to? Tama, no? It was predicted to be heart attack. Predicted to be ang true is 1, therefore heart attack yun, di ba? Tama ba, guys? Sa model natin, paki-check nga kung yung 1 is heart attack. Yung sa diagnosis.
Alam ko sir yung one heart attack.
One is heart disease.
Yeah, okay. 1 is heart disease, no? Yan. Dito. Where's that? Basta 1 is heart disease, no? Sa diagnosis. Sa una. Hindi. Ano ba to?
So,
okay, anyway. Pag 1, guys, heart disease, no? So that's true. Okay, so what does this table give us? Itong table na to, it tells us, guys, na ang predict niya na may heart disease, ang may heart disease na predict niyang tama, 64. Okay, correctly predicted na may heart disease. Tapos ito, predict niya na may heart disease, pero wala namang heart disease. So wrong prediction to. Ito naman, predict niya na walang heart disease, but ang reality, ang actual, may heart disease siya. Ito naman, predict niya na walang heart disease, tapos actually wala siyang heart disease, so tama. So it was able to get 125, no? 125 out of 153. Okay, so here you can see that the accuracy rate is 81.7%, yung tamang prediction niya. So that's 125 out of 153. Okay, may mga iba pang measures, but we will not go into that. May sensitivity, may specificity. Okay, you can just look at how those are computed, but they're also important in certain cases na kung talagang gusto mo mag-deep dive dun sa performance sa model, you can look at the sensitivity at saka specificity at saka yung NPV, no? Okay. All right. So ito guys yung high, yung MI, yung FA at saka yung CR. Yung kaninang ano, yung kaninang pinapakita dito. Yan. Hindi, saan yun? Saan yung pinakita kanina? Ito to, no? So outcome cost to, no? Sorry, I forgot guys. Dati medyo nakalimutan ko kung ano yung implication nito, no? So anyway, sige, alamin na lang natin or you can check on your own ano yung ibig sabihin nitong mga ano, yung high, MI, but they're not the counts, no? Yung cost siya. It has something to do with the cost. Okay. Hello?
Sorry, busy ako, sir.
Sorry?
I disconnected.
Okay. All right. So, we can actually plot, no? Mas maganda kung ipa-plot natin. Ito na yung ganda guys ng ano ng FFT kasi pag plinat natin, kitang-kita natin guys yung model na yon. Okay, so let's plot that. We're going to use the plot function. So here, plot. Okay? And then ipa-plot natin si heart. Diba si heart FFT. Okay? And data natin is equal to anong data natin guys? Ang ginamit natin yung train, di ba?
Yes, sir.
So data, ang lalagay natin dito, train. Okay. So let's plot this. Hindi siya, if I put here heart underscore train, tingnan natin. Okay, nag-error siya, no? So dito sa data, ang kailangan niya, hindi yung heart train. Kasi dito, yung FFT guys, FFT na function natin dito, ito. Okay. Kita nyo guys?
Yes, sir.
Yung data natin, this means yung ano yung train data, no? So that's why we're using it here. Nasa syntax na kasi ito, no? So yung train. Later on yung test, gagamitin natin test dito. So plot natin. Okay, and you have a very helpful plot here. So kita nyo yung plot. So i-ano ko lang to, i-maximize. Okay. Right. So sa lahat ng mga outputs guys, itong FFT yung isa sa pinakagusto ko, no? Kasi very comprehensive siya. Okay, let's take a look at this. Ito nga yung title ng ano natin, di ba? ER decisions. All right. N is equal to 150. Di ba? May 150 na ano na observations ng ano. Dali guys, 1 minute.
Hello?
Wait lang dos.
Ano ko na DC na naman ako.
Umuulan kasi.
Oo nga, hirap talaga po umulan.
Okay, so let's take a look at this guys. Madaling ano siya, madaling maintindihan, no? Okay, number 1, ito 150 yung train data natin, di ba? 150 yung observations. So 84 doon, yung actual 84 are stable. Okay, let's check nga. Let's check. Confirm lang natin, no? So dito table natin, table. Okay, so we have heart, train, And then yung diagnosis, no? Ay, wala. Wait. Ano nangyari?
Baka ano sir, heart dot.
Ay, sorry. Kung ano. Heart.train pala. Sorry. Heart.train. Okay, yung true, yung false guys, ibig sabihin yung walang heart attack, no? Yung true, yung 1, yung may heart attack. 84, 66. So that confirms our plot. Okay, 84 yung stable, yung walang heart attack. 66 yung may heart attack. Okay, so 56% yung stable, 44% yung may heart attack. No? Probability ng heart attack, probability ng stable. All right, then take a look at this. Ito yung FF3 natin. No? So first, you use the thal. Okay? Of 7, ibig sabihin 7 branches to, no? 7 decisions. 1, 2, 3, 4, 5, 6. FF1, bakit 7? 1, 2, 3, 4, 5, 6. So 6 lang. 1, sinasama yung taas.
Second opinion daw po yung
2, 3,
7.
4, 5, 6. Ha? Ikaw Celso Okay, I don't know what 7 is. Akala ko yung ano siya. Hindi naman pala, no? 1, 2, 3, 4, 5, 6. Hindi rin. Okay. I'm not sure guys kung ano yung 7 na to, no? FF3, number 1 of 7. Hindi naman ibig sabihin ng pitong trees. 1, 2, 3, 4, 5. Okay. Yung mga nodes guys, no? Isa, 1, 2, 3, 4, 5, 6, 7. Yan. Okay. So this refers to the nodes, no? Okay. So una guys, if thal is equal to RD, FD, then heart attack agad, no? Decision heart attack. Tapos, based on this decision, okay, 47 daw yung tama na decide nila na may heart attack, 16 yung mali. Kita nyo dito guys?
Yes sir.
Hit, ibig sabihin tama yung decision na may heart attack. Okay? False alarm, ibig sabihin sinabi nilang may heart attack pero hindi pala. So that's 47 out of, so this is 63, no? 47 out of 63. $47 out of 63 yung tama nila, no? Paki-divide nga natin 47 divide by 63. Anong ratio yun?
0.74603.
74%. I-add pa natin to. Ito, 54 divided by 66. 54 kasi yung tama eh.
81.81.
81.81.
81.81. Ito yun guys, no? Yung sensitivity. 81.81, that's 82. Ito yun. So yung correct na decision na hindi na magkaka-heart attack. Okay? So yung correct na prediction siya na magkaka-heart attack, that's 81.8. Ito yun yung sensitivity. Okay? So let's go here guys. Let's go here. Sorry. So yan, heart attack ano? Tapos itinanda yung CP, yung chest pain. If it's not equal to A, then answer stable siya. So at this stage, tingnan natin yung tamang prediction. It's called rejection kasi rinireject natin na may heart attack, no? So tama na rineject na may heart attack, 55. 8 yung mali. Okay, ibig sabihin dito, sinabi natin na stable siya, pero hindi pala stable, may heart attack siya. All right? Get the point, guys?
Yes.
Okay, and then go to CA. And then pag less than or equal to 0, and then stable siya. So dito sa stage na to, out of 15 na lang natira, 11 yung tamang ano nila, prediction, 4 yung mali. The rest, guys, kung greater than 0 yung CA, pumunta siya dito. So at this juncture, 7 yung tamang na-predict, 2 mali. So yung tamang prediction sa stable, no? Dito, na walang heart attack, ang tama is 55 plus 11. So that's 66 divided by, ilan to, yung mali. 66 plus, ilan to? 66. Tapos yung mali, 8 plus 4, that's 12. 66 plus 12, 78. Okay? So ang tama dito, guys, 66 over 78. Saan yun? Pakidivide nga.
66 over, sir, ano?
55 plus 11, that's 66, divided by 66 plus 12, 78. So 66 divided by 78.
Hey, sir, 66 plus 12? Yeah. So, 84.61.
84 point ano?
61. 62, rounded off.
84.61. So wala siya dito. Kasi yung tamang ano no, yung tamang prediction niya 55 plus 11 tama 66, di ba?
Yeah.
66 and then 8 at saka 4 yung mali, 66 plus 12. So that's 78. So 66 divided by 78.
84.61.
84.61.
84.61. So wala siya dito, no? Okay, kasi ito guys, yung mga measures na to, they are measures of measures siya na tawag ito ng yung tama at saka mali, no? For example, yung accuracy natin, guys. How many all in all were correctly predicted? Diba yung diagonal sitting correct prediction? So that's 54 plus 66, that's 120. Tama ba? 54 plus 66, that's 120.
Yes.
Divided by 150, no? So ilan yun?
0.8.
0.8. Ito yun, no? Okay, that's the accuracy. Ilan yung overall tamang prediction divided by the overall na overall na respondents natin. So accuracy natin. So I leave you guys to look at this. Ano tong mga to, no? Dali naman ma-research yan. Kanina nakuha natin sensitivity. Okay, yung specificity naman.
Sir?
Yes?
Sorry, can I go to the bathroom?
Yeah, sure. Go.
Sorry.
So, stop muna kami William.
Sige, sir.
We'll wait for you kasi para wala kang ma-miss. So, pause share ko muna to. Tapos, pause recording. Okay. Ito, accuracy, 81.7. Where did you get this? Tingnan nga natin to, guys. Hindi, to? Sorry. Ano ba ginamit ko dito?
Ayun, sir, right?
Saan ba tayo?
Sir, yung sa pagkatapos ng frame, yung plot.
What about 153 to? Di ba 150 lang?
153 din yung akin, sir.
Okay. Kasi sinama na niya 153. Kasi yung 153, that's that's a testing data. Diba? Data, heart.train, data.test, heart.test. So apparently guys, yung heart FFT, yung print natin, accuracy nito ng testing data. Diba? N is equal to 153. Pero dito sa yung pag-plot natin, 150 yung ginamit niya. Okay. If we use, dito sa ilalim, i-plot nga natin guys yung ano. I-plot naman natin yung
150 po talaga yung ano eh. Heart that train.
heart that train o 150. Pero
Opo.
dito, dito kasi bakit 153? Di ba?
Mm.
Ibig sabihin, ang ginamit niya dito, yung test. Review natin ng konti. So, yung heart F15 natin. So, diagnosis, regress on everything. Ang data natin, heart that train. Ang data test natin, heart that test. So, when we printed the object heart F50, ang nangyari, ang linabas niya, yung accuracy ng testing. Testing to eh. Diba? Subukan natin i-plot guys yung ano. Control C. Oh, yung plot yung test ang i-plot natin sa ilalim dito. Okay, dito. Let's use now test. And let's plot this. Ayun, 153 ito. So ito yung test data. Alright.
Okay, yeah.
Yan, di ba 153?
Yes,
And
sir.
then, ang tama niya, 64. Ang accuracy niya, 82. In fact, mas mataas pa yung accuracy niya kaysa dun sa training data. Di ba? Right? Agree, guys? Kasi sa training
double
data,
check. Yeah, 80.
80 lang eh, di ba?
Mm.
So this is an instance na yung unobserved niya, yung hindi niya ginamit para dun sa training, sa pag-generate ng FFT. And then tinest natin, mas mataas pa yung accuracy niya. Tapos going back to the training data, meron, naalala nito guys, yung rock natin. So pinaplot dito yung specificity at saka yung sensitivity. Ito yung sinasabi ko sa inyo guys na ano, may comparison. So ito, these are different models, no? So fast and frugal trees, yung classification and regression tree, logistic regression, random forest, no? RF, and support vector machines. These are tools in machine learning.
Mm.
So pinaplot niya yung sensitivity at saka yung specificity. Okay, so ito yung number one, si FFT, andi dito tayo. No? In terms of sensitivity, okay, mataas din siya, no? Although si number 2, sino ba si number 2? Si CART, number 4, bakit 7 to? Okay, I think we have to check more. 1, 2. Kasi ito si FFT, no? Tapos hindi kasi masyadong clear yung ano. Ano ba to? This is CART. Yung color blue, linear regression. Ito yung parang pink RF din siya. Ito ba si RF? Tapos meron support vector machines. So it's a comparison of your different methods, okay, in terms of sensitivity and specificity.
So, sir, meron pong 7 methods for FFT. Since 7 yung green dito. Ito, no? Yung 7, ano? Hmm.
Okay, let me check this guys. Hindi ko pa masyadong napag-aralan to, no? As far as I know, ang alam ko dito, yung mga naka-color code na 5 to, no? Ito si CART to. Ito si
LR.
logistic regression. At saka si support vector machines, no?
Mm.
Okay, and it's a comparison of the different methods. May linagay akong pointers dito lang, konti, no? Let's try to take a look at that. Ito. So the bottom row, ito yung confusion matrix natin. Okay, and then yung ROC curve, ano, compares the accuracy of the tree to other algorithms. Hindi ko pala diniscuss, no? Hindi ko diniscuss ng in greater detail. Okay, so yan ang next meeting, hindi ako nakapaglagay ng notes dito. Complete na yung notes ko dito eh. Hindi ko na nalagay dito, no? Okay, so kulang natin to, no? And yung specifically how this was computed, yung accuracy testing. That's very easy kasi ano lang yan, yung formula. Okay, one good thing about the pwedeng i-define natin kung anong gusto mong Kasi ito, we let the model itself, we let the software itself, we let the package itself run the algorithm, and then siya nagsabi kung ano yung magandang tree, no? Okay, but if you want, pwede tayo mag-create ng sarili nating FFT, no? So for example lang to kunyaring cholesterol, if the cholesterol is greater than 300, then dapat heart attack. Tapos if age is less than 50, stable siya. And if the slope is either up or flat, tingnan natin ano ba yung slope. Table natin, table. Okay, heart, brain, underscore lagi. Di ba that train, and then let's see, yung slope. So yung slope, guys, either down, flat, or up. Okay. So sabi dito sa example lang to, no? We can define our own parameters. If the cholesterol is greater than 300, may cholesterol dito, di ba? Ayan, yung call, no? If the cholesterol is greater than 300, then gawin na siyang heart attack, no? If the age is less than 50, then stable siya. And if the slope is either up or flat, then gawin siyang heart attack. Otherwise, kung down siya, stable. So you can create your own FF3. Kunyari, field of expertise mo to. Kunyari, doktor ka. Tapos alam mo na kapag ang cholesterol nag-shoot up to 300 yan, ay ano na yan, siguradong heart attack na yan. So this is based on maybe personal experience or personal knowledge. So a person who is steeped into this, alam niya yung mga nuances nitong nitong data na to, nitong field na to. He can come up with certain parameters to predict whether it will be exposed to heart attack or stable. So let's do that. How do we do that? Okay. So i-create natin dito, guys. Gawa tayo ng custom FFT natin. So once again, guys, FF3 ulit tayo. FF3 naman yan. No? Okay, so simula ulit tayo sa formula natin. Formula is equal to, again, diagnosis yung dependent variable natin, and we're going to regress it on everything, no? Okay, regress on everything. And then, comma. Pareho lang naman yung data natin. Data, okay, is equal to data, heart dot train, di ba? Okay, and next na hinahanap, kulang ko ng heart. Ang next na hinahanap yung data dot test, no? And it's equal to heart dot test. Okay. Ano pa? Nalagyan natin ng main title. Let's call it modified tree kunyari, or any name you want. Okay, tama. What else? In decision labels natin, decision dot labels. Again, ganun din. Is equal to C, either stable kung 0 or H attack kung 1. Okay. Yan. Alright, then idadagdag natin, guys, yung yung sarili nating our own parameters, no? Comma, O sige, let's call it my.3. Okay? My.3 is equal to so ano natin if the variable cholesterol is greater than 300, no? Ano yung predict natin dito? Predict attack, no? Right?
Yes, sir.
Predict attack. So dapat predict heart attack. Okay, then i-period natin to. Tapos yung next natin, if age, di ba? If age is less than 50, sa simula lang yung natin. If cholesterol is greater than 300, predict heart attack. If age is less than 50, then predict stable. Diba? And then, period. Okay, ano pa yung huli? Dito, if slope is, then brackets natin. If it's either up, okay, or flat, diba? Close natin yung brackets natin. If it's either up or flat, then predict attack, age attack. Then period natin. Enter. Otherwise, predict stable. Period. And then close quotes, and then parentheses. Sige, tinan nyo muna ha. And then ipa-plot natin to. Okay. Custom FF3s, formula natin. Ay, na-doble FF3s natin guys ha. Sorry. Doble yung FF3s natin. Diagnosis, data test, main modified 3 decision that labels, stable or heart attack. My.3, if cholesterol is greater than 300, predict age attack. If age is less than 50, predict stable. If slope is equal to up or flat, predict heart attack. Otherwise, predict stable. Period to. Okay, close natin yung quotes and then close parentheses.
Okay na, sir.
Ha?
I think okay na.
Okay na?
I think.
Wait ha? May sandali.
Let's see.
Stable. Parang sobra ako ng, hindi, sorry, ito pala. Hindi ko hinahanap yung open parenthesis ito. Open parenthesis and then dito yung close. Kaya iba dito linalagay yan. Ginagayan nila. Yan. Okay. I think we're okay, no?
So yung last parenthesis dapat nasa ilalim?
Pwede naman dito. Doesn't matter. Linagay ko lang para alam ko na yun yung ano niya. Yun ang partner niya. Kasi hinahanap ko dito yung partner niya. No? Hindi ko makita. So na yun, bakit may close ako dito? Yung pala, andi dito. No? So, parang ano siya, visual aid na makikita natin na yan ang partner niya. No?
Okay.
Okay, so run natin, guys. Okay, sana okay yung syntax natin. Alright, good. Okay yung syntax natin, no? So plot natin to. Plot. Plot natin, we call it custom, di ba? Custom, yan. Custom FFT. Then comma data is equal to, let's use yung, sa test data na natin gawin. No? Kasi yung kanina, yung sa test data natin, ang accuracy natin, di ba, 82%? Let's see kung gumawa tayong sarili natin na ano, without using the algorithm of the FF3s. Let's see if it's better. Yan. Ang layo.
Ay.
54% lang. Kasi hinula-hulaan ko lang naman yan. Eh, no? Hinula-hulaan lang naman natin. So, 54 lang dito guys, accuracy. Okay, so this is an instance where masasabi natin na hindi maganda yung ginawa nating model. Dito sa model na to, isang chance lang yung heart attack. Eh. Ang daming errors. Oh. Accuracy niya is only at 54%. Tapos, ang baba niya, sa sensitivity, ang baba niya, yung number 1. Kasi, maganda guys, yung higher, yung sa rock, dapat, andun siya dapat sa pinaka-optimal. Eh. Okay, so this model is not a good model. Hindi siya optimal. Okay. Now, pwede nyo guys, siguro as an assignment, di ba yung ginamit natin yung nag-logistic regression tayo? Anong data ginamit natin? Yung accept, yung yun, di ba?
Accept
yung sa magdo-donate.
Magdo-donate?
Yung sa parents.
Yung kung hindi napasok sa school.
Yun nga. Yung accept or not accepted, di ba? Yung
accept or donate.
Accept or donate. Accept or not accepted, di ba? Yung admit or not admitted, di ba?
Yes, sir.
Yes, sir.
Now, tingnan nyo guys yung logistic regression natin doon. Tingnan nyo yung accuracy niya. Then naka-define naman doon guys yung training and testing data. And then gamitin nyo ngayon itong FF3s. And then compare nyo. Pwede ba natin gawin yon? Yes, kasi logistic yun eh. So any logistic regression model can be run using this one. Okay. All right. Actually, ang susunod natin guys is random, no? Itong random forest. Now, ang gagawin ko muna for now, guys, kindly, okay, is it okay guys na pause muna tayo ngayon, no?
Yes, sir.
Okay lang ba, guys?
Okay lang naman.
Kasi naka 2.5 hours na tayo. Pero yung mga susunod guys, medyo babawi tayo, magdadagdag na lang tayo. And I don't want them to start on the random forest kasi mabibitin tayo kung kasi mga 30 minutes lang tayo, no? Medyo mabibitin tayo. So may I request you guys to look at this. Medyo basahin nyo. May mga may mga binigay akong references. And then take a look at that kasi this is one of the most powerful. In fact, this is more powerful than yung fast and frugal trees kasi si FFT hanggang lang yan eh. Hanggang logistic lang yan. Ito si random forest guys. Flexible, sinisimulan ko lang tingnan yung binabasa sa inyo. Easy to use ML, machine learning algorithm. Okay? So, tingnan nyo lang guys, ano ba ibig sabihin ng hyperparameter tuning? Okay, it produces a great result most of the time. It is also one of the most used algorithm, yung random forest na to. Kaya sa tinawag na forest kasi, nag-create ka ng maraming trees. Di ba nag-decision tree tayo? Isang tree lang yung generate natin. Ang random forest, you can create 500 different trees. So imagine yung power niyan, di ba? Compared to only one tree, vis-a-vis, you have 500 different trees. So syempre, although it goes against the grain of the FFT, di ba? Yung sinasabi niya natin na the more the better, not necessarily true yun. But not for the case maybe of of random forest. This is a case where the more is really good, no? Ang ginagawa dito, guys, nag-a-aggregate siya ng mga trees. Ibig sabihin, nag-create siya ng maraming trees. Okay? At the same time, ano siya ng overfitting. So imagine, guys, na mag-create ka ng maraming models, pero you're able to avoid overfitting. Kasi may technique siyang ginagamit. Okay, kunyari, ito. Makaka-generate siya ng 500 decision trees. Eh, yung mga unang ginawa natin, di ba, yung party package at R-part, isang decision tree lang yun. Di ba? If you want another tree, then mag-iba kang set that seed, no? Para iba yung training natin at saka testing data. So you'll have to replicate that several times. Ito, in the model itself, in the functionality itself, you can already generate that 500 trees. Imagine, guys. Yun nga lang, pag nag-run to, medyo it will take a bit of time. Kasi nga nag-generate siya ng maraming trees. And then ina-average niya, hinahanap niya yung pinakamagandang solution. And it makes use of what we call a bootstrapping. Familiar ba kayo sa bootstrapping, guys?
Narinig lang dati.
Narinig lang. Sige.
Yes, sir.
Next meeting, guys, ito yung i-discuss natin. We will, siguro, next meeting, magra-random forest tayo. Siguro, isama ko na rin yung support vector machines. Pinaka-last natin, guys, yung XGBoost. Okay. Si XGBoost, guys, yun ang talaga machine learning. Kasi, parang black box siya. Maglalagay ka doon. Hindi mo alam kung anong ginagawa niya, tapos mag-generate siya ng output. So that's what really, dyan nanggagaling talaga artificial intelligence. No? So that will be the last topic of machine learning for supervised. And then siguro just one or two examples of unsupervised. Tapos babalik na tayo dun sa kasi nagagalit sa akin si Celso na bakit daw hindi ni-discuss yung trading software.
Grabe, sir. Hindi naman.
Joke lang. O guys, gentlemen, pag-itingnan na lang to para next meeting, pag nag-discuss tayo, medyo may idea na kayo, no? Kasi mas complex yung random forest. But the results are really a lot better than just the ordinary decision tree. Okay, paki-review na lang ulit yung guys, yung mga parameters doon, yung accuracy, yung PCI, what do those mean? Sensitivity, and then yung ano pa isa sa sensitivity, and then the specificity sa FFT, no? Sa measures na. All right?
All right.
Sige, so
Yes,
stop muna yung recording natin. Ipo-post ko to, no?